This is a talk about rural land values in Chile. Where's the button? And how do I turn it? It's up and down. Okay. And we're going to talk about land values at the level of municipalities, which are like counties in the, say, the United States or townships in the East Coast. They're not as big as counties in California, say. There's 372 municipalities in Chile. So it's smallish geographic areas. The main question is what factors explain the rural land values. And we started out worrying about anticipating the impacts of future possible climate scenarios. But an additional question was, beyond the characteristics of the geographic areas that we're looking at, the sort of the basic characteristics, soil types, the climate, distance to markets and the like, does information regarding specific activities add any information to the value of the land in rural areas? And we're going to find out that it's true in the case of wine and not true in the case of other activities. And we start out with the standard assumption that the value of land in some area should reflect the present discounted stream of the possible activities, and perhaps some unrealized activities as yet in the future. And once you have adjusted for those characteristics, those basic characteristics in a place, such as the climate and the like, you could assess the value, at least in cross-section terms, the value of the land without reference to the specific activities, because the activities are determined by the characteristics of a locality, and so then once you've accounted for the characteristics, the activity wouldn't add much. But there are reasons to think that information about the activity in a cross-section type of analysis would still add information. And one would be if the activity added significant and mobile investments to the land. And so if you observe land prices, you're observing those investments. And the activity would just be an indicator of, at least on average, what those investments would be. And the obvious possibility is the plantation of the vineyards themselves or plantation of fruit trees. In Chile, we have a lot of table grapes, for example, and apples and blueberries and a whole bunch of other things like that. That's one possibility. The other possibility is there are other values associated with certain activities. For example, in the case of wineries, we have the cachet, the prestige of living in an area that grows wine. We have tourism associated with it and the like. And that's the one that we're trying to see if it exists. So land use composition could offer additional information beyond that of intrinsic characteristics of the climate and the like. And here is my simple graphical representation of what's going on. We're going to be interested in what's called market potential. It's essentially a measure of proximity to high-income areas, and the distance figures into this. And this is a von Theunen model where different activities are selected based on essentially distance to market, cost of transport and the like. And so having information about the distance for market is essentially determining also your activity. And you could correlate the activity with the land values, or if you had the distance for market, you could just skip knowing the activities. Essentially, it would be redundant information. And that's essentially our empirical approach is, well, let's look at the correlation between land values at the municipality level and some basic factors, climate, market potential, other things. I'll go through them. And then we add the activity levels of certain wine making, fruit production, that type of thing, pastures and other farming activities. We add that and we see if it adds any information or not. We're also going to account for some geographic correlations. It's we're going to show that that's pretty important here, and the possible spillover effects that one locality which has high land values will probably have impact on the land values of neighboring localities. And this needs to be refined a lot, in part because I believe there's endogeneity all over the place, and we have to resolve some of those things. Land value data, it comes from a huge data collection effort over various agroecological zones. We did this as a part of this larger project. We use land registries, which record the official transactions. The land transaction gives you the dimensions of the property, the value of the transaction, and a few other things, but it doesn't record the activity that's ongoing on the land. Sometimes it'll have some information about irrigation, but most often it's simply a record. So, as it turns out, we can collect approximately 32,000 transactions for these 4 different years. We were interested in what's the number of transactions that take place over the years. This covers the main production regions, the agricultural regions in Chile. The initial analysis shows some significant variation of the value. This is in real terms, according to the size of the transactions and the region and the like. And this is just a summary of the number of recorded transactions. This was of interest by itself. That where's the little button? Oh, I'm turning it the wrong way. The increase in the number of land transactions in rural areas went up more than double over the course of this, large change here even during the latest decade. We chose 1997 and 2007 because they correspond to agricultural census data that we have. These are the number of hectares recorded. This is on the medians. We ended up using medians because there were some transactions that were of incredible size, like 10,000 hectares somewhere up in the mountaintop, and very small values, or some parcels that were astronomical values on them. So we used the median number just to reduce that problem. And the mean number of hectares, you can see, has collapsed between 1980, which was that was the plebiscite for the Constitution under the military government, and then 1990 was the first year of return to civilian rule. Well, in that period, there was also extremely high growth in agriculture, and not only did the number of transactions, the number of the activity in land markets increase, but also the size of the parcels fell. And to date, it's on the order of, say, 2 hectares. And what happened in terms of the actual value per hectare, these are in Unidad de Fomento, which is a inflation-adjusted official formal price. So you make contracts in this, especially, say, hipoteca, which is mortgages and that type of thing you have. And you can notice that the value of the transactions, the value per hectare went up from, oh, by the way, UF is probably on the order of $35 to $40, I think, US at the moment. And it went up from about 15 UF per hectare to over 100 UF per hectare. And this has shown the incredible increase in the profitability of agriculture in Chile. Well, our model, basic model of the land values is hedonic. Essentially, we are we can motivate this by saying the value should account for, it should be the envelope of all possible activities in the future, and then we'd look at the maximum of that, and that should be the value. Well, it's almost impossible to even in a very simple model, to come up with something that's analytically resolvable, and so we all break down and use a generic hedonic expression, which is thought of as just a first-order approximation of what's really going on land values. And this is I'm going to just tell you the results with this graph right here. So if I run out of time, you'll have already know what's going on. This shows the land value per hectare in municipalities, 1997, 2007, for which we have exact numbers on with respect to the allocation of land. The blue is without any vineyards, or less than 1% of the land is used in vineyards. And the red is more than 1%. In the last session, Kim showed you that about 10% of the acreage was in grapes, but that's table grapes as well as vineyards, as well as wine grapes. In the samples that we have, only about, of the municipalities that have any wine grapes in them, they only average about 4% of the cultivated land. Well, as you can see, that the value on the vertical axis, we have the value of the municipalities. The median value of municipalities with vineyards is considerably higher than without, but that's also true in the case of fruit plantations. And now the question is, all right, so suppose we ran a regression of all the characteristics, climates, distance to markets, all of that, and we tried to predict the value of the land, and then we added the fruit information. Would we be able to explain anything? In the case of fruit, no. All this difference we can explain by the physical characteristics of the place, but not in the case of wine grapes, and that opens up some interesting things. What are we leaving out of the regression, or perhaps there are these spillovers or significant investment effects? Our econometric model is essentially a spatial model where the dependent variable depends on, depends on the explanatory variables, the standard x variables, but also on your neighbors, where we determine, so this is the land values of the surrounding area, and it's weighted by the distance, inverse distance. So right next door will have a higher impact than the people farther away, and this row, which I'll just tell you, it turns out to be 0.6, it's very high. The correlation with your immediate next door neighbor is extremely high. And in all our models, the geographic question is very important. And then you have a possibility that the neighborhood X variables, the neighborhood explanatory variables, can also impact your local variables. It turns out there's very weak evidence that that's true. This is the sort of the direct effect right here. The beta impacts the land value. But you can have the long-term, what corresponds to a long-term effect in the case of autocorrelation in time series. You have the total effect of which would be your beta multiplied by this inverse of the local correlation, the distance correlations. Now let's just go to the x variables. First thing is that the parcel sizes are highly correlated. Are highly correlated with the per acre land values. So we're going to add that in there. We're going to come up with a market potential index, which is essentially a weighted sum of all of the income levels of the municipalities near and far. The weighting depends on the distance. This is used in the economic geography literature all over the place. And this is just a map showing those The darker areas are the communities with high market potential. The dark, very dark area there is Santiago. The main grape growing area is down here. It's not the same as distance to the capital or anything. It depends on the population sizes and the incomes generated in the municipalities. By the way, this dark up, this is from north to south. This is Santiago. This area here is a mining area. This area here is La Serena. This area here is Concepcion, for those Chileans who want to know. We also included climate variables. Unfortunately, we had to construct all these things from meteorological stations which are not designed for economists in mind. These are mainly designed for hydrological type of models because water is so important. But we took them, essentially, from this, we constructed climate data for each municipality in the rainfall and temperature. As it turns out, pretty much everything is summarized by one number because in the case of Chile, this is from north to south, and the amplitude of the sine wave is essentially a function of the mean temperature during the year, and so everything boils down to essentially just averages and coefficients of variation around of the numbers. Then the other X variables, we classify the municipalities according to their ruralness and urbanness, whether there's mining or not in the comuna. We also have the soils, the 7 agroecological zones. And then finally, the activity levels are from the ag censuses, the annual field crops, grasslands, forests, fruits, which doesn't include vineyards, and then vineyards. By the way, there's very little variation in time for the case of vineyards at the level of the municipality. And so going to the results, we had one model where we just said, does the municipality have more than 1% of its land in vineyards or not? And then we used other models where we used the simple percentage of land in vineyards. We could do them for the 1997 and 2007 pair, which is where we have most of the information, or we could use all 4 periods. We looked at the OLS, the random effects, and the like. And this SDM is the spatial Durbin model, which has that's the model I showed you before, which has all these interactions with your localities. These are the results. I won't go through it. I'll just note 2 things. One, the R squares in these things were surprisingly high, as it turns out, to me. But here's the main thing. Here is using the average of the share of vineyards in those 2 years. You come up with this value of about 6, which means that a 1% increase a 1 point increase in the percent of land, agricultural land in vineyards will increase your median value of land in the municipality by about 6%, which is pretty high. And the other thing to note here is that fruits actually, it has a negative sign, but it's a 0. That once you accounted for all these other variables, the temperature, the precipitation, and the like. The region effects, we put region effects, we put the soil effects, we put the community type effects and the like. And that's what's happened. So how do you interpret the result? Well, there seems to be something about vineyards, about having vineyards in your municipality. I got 1 minute. From the dummy variable model, it says that, well, when you go from no vineyard to vineyard, you increase your median land values by about 25% at least. And in some models, it goes up to 50%. It's pretty high. And then as I was telling you before, in terms of the percent model, where you're using the percentage of vineyards in your coverage, a 1 point increase in the percentage of vineyards increases your median value by at least 3%. That's sort of the minimum of the models that we use. That's looking at the OLS up to all these different combinations. But in most models, it's on the order of 5 to 7%, which, by the way, given that the average percentage of vineyards is 4% in those municipalities which have it, and so you multiply 4 by this 5, and you'll get up to your approximately, it's around the 25%. But the other thing is, ceteris paribus, the proportion of land and fruit production doesn't seem to add any information, and ditto for the other activities. So it suggests that the added value of vineyards is more than the value of plantations, because a good chunk of the fruit land is in it's in table grapes, and so it's in some sense it's very, very similar. Other results: climate's very important. Market potential is extremely important, by the way. Between the region with the least to the region of the highest, it adds about 40% to the value of the land, just ceteris paribus. Possible sources, well, we have to go back to missing variables. Maybe there's something about the location of vineyards that we're missing in these sort of gross municipal level characteristics. That's one, so we have to investigate that. The other is there could be special and significantly larger land-tied investments, and they have to be significantly larger for this, because it has to be something more than just putting the vineyard in there and the trellises and all the things that are associated with that, and just the level of labor, for example. The level of labor costs in table grape is extremely high. And the other thing is we want to look at is the spillovers into all land of having local wine. And this is what we think might be happening. And so, in order to look at that, we're going to have to break down the wine. It's not just wine land. Is it Cabernet? Is it high-end varieties versus low-end varieties? That's one thing we can look at, and we have an idea of doing this, but we don't have the data set yet. The other is, if it is tourism, well, then let's locate the touristic places in the wine zone. Let's go after and geographically locate the wineries and throw that in. That's a project. And maybe the other thing is we need just more information on the basic characteristics. And with that, I am finished. Thank you.